So, what we have achieved so far is the symmetric part of the polarization tensor, which is obtaining the symmetric part of the polarization tensor, that is given by pi L times u mu nu by u tilde square plus pi t times r mu nu, and both these indices are symmetric under the exchange of mu with nu and nu with mu. So, if we write down the polarization tensor, say this is the 0 component, this is the 0 component, 0 2 0 3, similarly 1 0 2 0 3 0 1 1 2 2 3 3, so on and so forth. Mu interchanged with nu, nu interchanged with mu yields the same thing. That means we are at the diagonal level. However, it can, in principle, still admit one more term if we call it pi p, and we add this I here, epsilon mu nu alpha beta u alpha k beta, then you can see that this last term is both symmetric under the mu going to nu going to mu, and k going to minus k condition. That's fine. Under parity, the epsilon changes sign. Under charge conjugation invariance, u changes sign. So, the product is PC invariant, and it is as such time reversal symmetry is there built in it. So, for a theory which is CPT invariant, this last term is admissible. So, in general, the 2-point function can be constructed out of these second rank tensors and one fourth rank tensor and the two vectors. Okay. Now, having figured this thing out, let's try to see what happens when q of mu alpha is contracted with q of alpha lambda. You see it is u mu u alpha Now, these two sitting over here will simply cancel with this, and we will be getting back u of mu tilde u of mu lambda by u square. So, the product of two q's actually generate another q. Okay. So, this is a typical property of a projector. If two of them produce 1, so if you multiply here 3, then 3 of them will produce 2 here and will produce 1 q here. So 3 also will produce 1, and you can show that by continuing this multiplication process or contraction process, we'll end up getting q's only. Okay. R lambda rho is given by g tilde of lambda rho minus q of lambda rho. So if I contract r of lambda rho with r of rho delta, then you have g tilde of lambda rho minus q lambda rho and g of rho times delta, q of rho times delta, you get g of lambda rho tilde into g of lambda delta minus q of lambda rho times g tilde of lambda delta minus g of lambda rho times q of rho delta minus q of lambda rho times q of rho delta. These two things give rise to 1q, and if they give rise to 1q, my hunch is that R, when it is contracted with itself, then R in principle should generate another R. So what it means, we should get a factor of this lambda would survive here and delta would survive here, lambda delta. So in other words, R of mu nu, R of nu rho should give you R of mu rho. R of mu nu, Q of nu rho gives you 0. Q of mu nu, Q of nu rho gives you Q of mu rho, and you can verify this yourself that P with R gives you P and P with P gives you R. And you can try to assign for yourself the reason why these two peculiar results actually come. Alright. So now what we can do next is to try to find out the value of each of these components. For value of the components of these tensors, so you can see that for mu equal to 0 and nu equal to 0, R double 0 is equal to 0, R 0I is also equal to 0, and Rij actually gives you minus delta ij plus ki kj by 3 vector k square. That is the relation. And similarly, Q0 gives you minus k square upon 4k square. Q of 0I gives you minus k0 ki upon k square, and Qij gives you minus k0 square into ki kj upon mod k square upon 4k square, and P00 is of course equal to 0. Same would be P0I should be equal to 0, and Pij should give you I times mod of k times epsilon ij k into k. All right. So what we can do now is write down the Lagrangian as minus 1 quarter f mu nu times f mu nu plus half a mu pi mu nu times a nu, and this whole thing can be written as is equal to the Lagrangian. So, this part can be identified the propagator with medium corrections where d mu nu inverse can be written in terms of these projection operators as minus k square plus pi t plus q mu nu to minus k square plus pi l plus p mu nu into pi p. So, now you can see that in medium you do not have the denominator of the propagator inverse having a pole at k square equal to 0. So, there are new poles, those are appearing at pi transverse and at pi longitudinal. Thank you.